Okay, we'll discuss it. So today, so first thing is problem. One problem is there. One problem we can identify. One problem. So what is that problem? Using the EDM instruments, you will get only slope distance, not a straight distance. Sir, what is the slope distance? If you see, if you see one station here and one other station here, you will put a object to or tripod. So something tripod here, and we put a reflector here. Reflector. You send a signal, it will go by legs, go by this, and reflect it. It will come like this. So it has emitter, emitter, and reflector. So if you see what is the distance, you will get this distance. You will get this slope distance, not this distance. Understood? You can't get this distance, horizontal distance, or a straight line distance. Okay, you can't get it in these EDM instruments. You can't get it. So how can we get, sir? So simple. We already know it. We already know it. Once you get the distance of L, if you know measure the horizontal angle with respect to the total station, you will get this horizontal distance. Horizontal distance. So compulsory we have to use horizontal vertical angles to find out the horizontal distance, not a slopey distance. Slope distance only you can get with respect of EDM measurements, not a perpendicular distance, not a perpendicular distance. Understood? Not a straight distance or same plane distance. Okay, some plane like this, some like this is the topography like this. You will get only slopey distance, not a horizontal distance or straight distance. Are understood? That is the one problem. So we already know the EDM instruments are inside of the total station. With respect to the total station, you will get the vertical angles and horizontal angles. So no need of at all. So you will get the horizontal angle, vertical angle like this. If you set the total station, it will go like this, and you will get the vertical distance with respect to the total station. If you level the total station, it will give a straight vision. Later you will fix that so level pad. So later you will get the vertical angle with respect to the total station. With respect to that, you will get the EDM. So you will get the horizontal distance. Okay, that is the one problem you have to understand it. Okay, you have to understand later. So what we discuss, we will discuss it. See, EDM instruments classification. EDM instruments classification. Modulations we will discuss later. Okay, so modulations we will discuss later. Okay, so what is the classification? So classification is based on the waves, based on the waves which are using. So we will use the waves. Which type of waves uses? What are the different waves we are using in the EDM instruments? We will use the microwaves. Okay, visible range, and infrared. So these three different types of waves are using in EDM instruments. Remaining we can't use. Okay, those has high which has a high wavelengths, so we can't use it. Okay, so many problems arises. We don't understand those problems because these are all electronics topic, electronics, waves, signal processing, those topics. So we will use only these three waves in the EDM instruments. Okay, so high or low energy, maybe low energy, or otherwise high energy, we can't use it. These are the some in between those, high and medium, high and low. We will use these three radians. Okay, so see it is how they discuss how. So microwaves, if you're using the microwaves, it has a long range instrument, it called long range instrument. Long range. Okay, Frequency range, it is a frequency range. We use 3 to 30 gigahertz frequency range in those frequency, and it called as a tellurometer. Tellurometer. If you use the microwaves, we call it as a tellurometer. Are understood? We call it as a tellurometer. Okay. So okay, that's it. We call it as a tellurometer. Okay. So, and remaining thing we can explain like this. You see, it needs 12 to 24 volt batteries, 12 to 24 electric energy volts is required. It will use at day and night also. Day and night also. We can use it day and night also. No problem at all. Range. Range is 100 kilometers. See it is? That's why called as a long range. We can use 100 kilometers. Long range instruments. Okay. So it requires skilled persons. It requires skilled persons. These are the uh, these are the things we have to learn about the microwaves using EDM instruments. Nothing more than this. Okay. It is a long range instruments. Frequency range is 3 to 30 gigahertz. These are the called tellurometers. Okay. It requires 10 to 24 volt batteries. We can use it day and night also. Range is 100 kilometers. It requires a skilled persons. Understood? So next if you see visible range. If you're using the visible range, we can call it as a light waves. We using a light, na? We call it as a light wave. Light wave instruments also. You can call it as a light wave instruments also. Light wave. Light means general light, not a very light or weight. No, it's a light wave. Okay, are understood? The range is, if you see, frequency range, no, no need at all. Frequency range is no need at all. Okay, so wait. But if you take in frequency 5 to 10 power 4 hertz, not a gigahertz, just hertz. No need at all. But okay, 5 to 10 power 4 hertz. Okay, these are the medium range. Medium range. Sir, what is that range? I will see you. Okay, so it is called judeometer. Judeometer. Okay, gaudimeter antaru. Gaudimeter antaru. So that's our Indian pronunciation, I think. Geodometer, it's a better pronunciation. Someone called gaudimeter. It's not a gaudimeter, geodometer. Okay, so that's thing. See, it range is 3 kilometer. 3 kilometer in a day, 2.5 kilometer in night. 3.3 kilometers in a day, 2 kilometers in night. Sir, once I remembered that you said that these are not used in the daylight because the inference something, like I said na, last class I said like this inference something. So how can we overcome that problem? We will discuss later. Okay, we can use day and night also. Okay, no problem at all. So accuracy, if you see accuracy 0.5 to 5 mm per kilometer, that is the accuracy. If you measure the distance of 1 kilometer, it will give accurate as, maybe it will give very 0.5 to 5 mm difference is there. Actual distance and measured distance, that much accuracy we can get it. Okay, you can use day and night also. you can use day and night also. Batteries, I can't get that value. Okay, so it requires also some voltage, but I don't know what is exactly that voltage. Okay, so that's it. That is the light range, light wave instruments or visible range, anyone, anything you call. These are the ziodometers, these are the telerometers. Okay, these are the frequency range, this is the frequency range. Okay, so what is the wavelengths? We already discussed in a wavelengths. Okay, we already discussed where it is, this is today's class, no? So these are the, what is the wavelengths range? See, it is, these are the wavelengths and energies are understood. Low frequency to longer wavelengths. This has visible range has a longer wavelength. So no, this has a longer range. Infrared has longer wavelength. Okay, microwave has much longer wavelength. See it, na? Longer wavelength. What is the wavelength? No need at all. No need at all to remember that. We don't require that much deep. What is the range? But if you find out the range is okay. This is the range. This is the range. This is this is thing is the, I think, wavelength. This thing is the energy. If wavelength is decreasing, energy is increasing. So gamma rays, X-ray rays has a high energy. So that's why you can't expose directly with the X-rays or ultraviolet rays. Okay, because this has high frequency, high energy. Are understood? High energy rays. So, okay, if you see this, so this is a visible range. This is a microwave rays. So infrared, it has something somewhere here is microwaves. Microwaves. Okay, this is energy, this is a wavelength is increasing na? So it's 10 power minus 6, this is 10 power minus 4, 10 power minus 2, wavelength is increasing. Okay, those are the wavelength range. And frequency range, wavelength frequency is opposite. What is the exact values? If you see the diagrams, you will get it. No need to explain it. Okay, so next, infrared rays. Okay, next, infrared rays. So infrared waves, so if you see these are the light means very lightweight. Light means very, if you see, if you understand, Windows is very complicated. If you take an Linux or something another, if you take it, those are the light OSs. Understood what is the meaning of light? Is a, if you take an a OS of Linux or some other, they think they called as a very light OS. You can use very friendly. So that is the, if you're using infrared, these are the light waves, not a our seen light. So these are the two different meanings. Okay, light and economical. Okay, accuracy, if you take an accuracy, so okay, I will range the, I will put the frequency range. I will put the frequency range is 3 to 10 power h. 3 into 10 power, I already said that. If you take an a curve, visible is there, infrared is there, micro, visible, infrared, micro. Sir, this is high, this is low, and again this low. No, this will come in between this, but I will put visible range in the middle because we know it covered. So if you taken the, if you taken the wavelength, it will go like this: visible, infrared, and microwaves. Just now you see it. Okay, so that's why this frequency range is 3 into 10 power 4. Okay, so it called as a distomat. It called as a distomat. If you're using the infrared rays, we call it as a distomat. This is a geodometer, this is a telerometer. So, and also if you see, it is a medium, it is a long range, it is short range. It is a short range. Okay, it is a short range. So I will explain here. Okay, I will explain here. These are the economical and light and economical. Okay, light and economical. If you see accuracy, so what is the range? If you see the one booth lo up manappa. One up manara apeda. So range is 3 kilometers. Again, it's a 3 kilometers. Sir, it's a short now. I said it's a short range, but again it has range of 3 kilometers and less of 3 kilometers. Mostly we will use 1 kilometers, 2 kilometers. Okay. So accuracy is, if you taken it as a plus or minus 10 mm per kilometer. Plus or minus 10 mm per kilometer. It's a range. Okay, it's not a range, it's accuracy level. So okay, so if you see, it is infrared rays. Infrared rays you can't use in daylight. Sir, what is the problem in daylight? So if you have any problem in the daylight, that is for the only visible range. See, our visible range light na. So but why it is a problem in daylight, in infrared? So what is the problems? So I said it is a, you can't use in a daylight. You can't use in a daylight in infrared. So these are the specific classification. These things are the classification of the electromagnetic EDM instruments. But so someone said that it is a using in the daylight. Someone said it's can't using in the daylight. So what is the problem? What is the problem to using the waves? What is the problem using the waves or wavelengths, or, to measure distances or something, any other another, so another usages also? What is the problem in this range? So exactly what is the problems? If you see the problem, if this is the problems, if you're using any waves, if you said okay, if you're using any problem, using any waves, any different wavelengths in different waves, it requires, wait, disturbing. Wait.
Namaskar. Let us unitedly stop further spread of COVID-19 in our country. For the next few days, step out of your house only if it is absolutely necessary and stay away from crowds. You must remember three things. Wear your mask properly.
Hello, Suresh sir.
Hello?
Suresh sir,
హలో
సురేష్ సార్, నేను రెడ్డి సార్ని.
రెడ్డి సార్ చెప్పండి సార్.
ఈడ క్లాస్ జరుగుతుంది, సర్వేయింగ్ క్లాసు.
సార్
బాల పెద్దిరాజు, మన రాజు సార్ అనుకుంటా, అటెండెన్స్
అవును సార్.
తీసుకోవడానికి.
అవును సార్.
ఆయన మైక్ ఆన్ చేసి ఇంట్లో బూతులు తిట్టుకుంటున్నాడు. నాకు ఇక్కడ స్టూడెంట్స్ ముందు ఆయన పరువు పోతుంది, మా పరువు పోతుంది.
సరే సార్, ఫోన్ చేసి చెప్తాను సార్.
ఫోన్ చేసి మైక్ జాగ్రత్త చూసుకోమను. ఇంట్లో ఏదో బూతులు వాళ్ళు మాట్లాడుకుంటుంటారు అసలు.
సరే సరే
నేను క్లాస్ రికార్డ్ చేస్తున్నా.
అలాగే సార్, రికార్డ్ చేసి నాకు పెట్టండి సార్.
ఇంకా ఆఫ్ చేసేలే, క్లాస్ అంతా ఆఫ్ చేసి కాసేపు ఆగండి అని ఫోన్ చేస్తా అని చెప్పి ఆయన
అలాగే సార్, నేను చేస్తాను సార్ ఇప్పుడే.
ఆయన కలవలేదు, మీకు చేస్తున్నాను. ఓకే, చెప్పానులేండి. ఓకే, వినిపిస్తుందా? ఓకే, so what is the problem? If you release any wave, we required one emitter. We required one emitter. Okay, so now also receiver also, no problem. Receiver also placing the same equipment. Okay, but if you release the waves, receiver has receives so many waves in the universe. Are understood? Receives so many waves in the universe. So it receives a particular signal which was released by me or you. So is difficult task, because in universe someone is talking, some ultraviolet rays are coming from sun, ultraviolet rays are coming from, or microwaves are present in our universe, our surroundings. So many, not only visible range, microwaves, universe rays, gamma rays also there. But if you receive wave, so how it receives that signal, how it receives the signal. So because, okay, if you set some phenomena also, but it not only receives our signal, it receives another signals which has the same significance in the universe. It receives the same, but you can't decode it. You can't decode the what is. So maybe inference is there, inference is present, so many signals are inference. So how can you solve that problem? So how can we solve the problem? Okay, that is the question. Because our universe has so many signals are there. So if you send one signal, you can't exactly receive that signal, but if you receive that signal also, it receives so many other signals, it can't decode exact properties of the signal. Decode means how many waves are completed, what is the phase difference of that signal. Are understood? So it is the problems arising. Okay, these type of problems arising. So if you see, it is exactly what happened. A wave is generated. So wave is generated, it's a transmitted. Okay, it's a propagation. And once if you put a reflector, it reflect, otherwise reflect, and reception, it receives, and it's a distance measurement. Next is a distance measurement. Okay, these are the waves, these are the steps. Are understood? But these type of problems arising because it receives so many other signals, it can't decode it. So what we have to do, is we will modify our signals. Because if you see, our visible range are something there and remaining also there in the universe, we exactly deviate we exactly deviate our signal from those signals present surroundings are. because if our present signals has some range, our signal is far differ from our surrounding signals, then only it can easily diffract, is easily differentiate between our signal and the signal surroundings you. Okay, if you see, if any so many equipments are operating our ears, equipments are operating in the field area, the equipments also generate releases so many level of frequencies are understood. If you see in a field, so many some machine is operating, if machine is operating means it generates some frequency, maybe that frequency matches our signal, maybe frequency matches, maybe wavelength as matches, or otherwise energy is matching, or wavelength means our amplitude is matching. So if something is matching with our respect to our signal, so they will collide, they will inferent, they will mix it. So it can't easily so it can't easily differentiate between those signals, decode those signals. It has a problem. Are understood? So what we'll do? We will do a modification of our original signal, modification of our signals. Exactly here, generate modification of our signal. Modification means we will modify our signal, compare with the remaining surrounding signals. Maybe so many amplitudes, frequencies, wavelengths are generating or already present in our surroundings. We will far differentiate our signal from these things. Okay, so later generate modification, transmitted, propagation, reflection, reception, and again it has demodification, and decode it. These are the things, these are the things will happen. Sir, what is the modification, how we will modify signal? Modify signal, if you see in general, so many satellite phones are using cell phone signals, telephone signals, cell phone signals. Okay. So internet has also, if you send a message or if you send an email, it has a signal. So how the data is transferred, so much data is transferred surroundings of us, but how it will decode it? If some message is forwarding some other place, maybe some other person also sending messages, those are the two signals na, it can't interfere. Exactly, it receives the same place. So at those outcomes, at those out point, exactly decode the data. It can't interfere. How so many data, so much data is transferred, tvs, satellites, radios, everything is a data transfer na? But if you see previous 20 years back, if you switch on the tv, some rain is happening, signals is inference, so the picture is colliding, something is blah 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 blah, so the signals are matching, or the inference is happening, some signal, some other signal is colliding our signals. So now we, if you see nowadays, there is no such a problems arising, because so much modification techniques are, modified signals or techniques are present here. Okay, so that's why modification is required. So how they will do modification? So that is the question, that is the last question we are raising. So if you see, it is, this is a electronics topic. I don't have a command on this topic, but I will select one particular video of how to modify the signals. I will show you. Okay, so this is electronics topic, electronic wave modifications. Okay, so I will show you. First I will, modification means it's a modulation, it's a called modification means it's a modulation, you can call it as a modulation. Okay, demodulation. Okay, demodulation. Now I will present. Now we will listen. you don't need at all. So because we just use analog signals, not digital signals. So that's the modulation techniques. So these are the common, not in a civil engineering, everywhere. What are the modulation techniques, why it is required modulation? Can you understand? Yes. So how it is happened in the modulation techniques? So base signal and the carrier signal, we will impose our base signal into the carrier signal. We will impose our carrier message signal or a base signal into the carrier signal, and it will propagate and reflect and receive. Later it will decode, demodulation. Are understood? That's the theory. So how different ways is, either change the wave frequency, either change the wavelength. That's it na. Either frequency change the wavelength. So we will impose those frequencies or wavelengths. Wavelength means width, frequency means amplitudes. So frequency amplitudes, they will change it and will transfer the signals. So okay, why it is need a modulation technique also they explained, and I explained. That's the theory na? That's the thing. So this is a triply or easy topic. We understand it, that's enough. No need to remember our to digital signals and everything, we don't require at all. So we require how much we require, we will get it, not everything. Okay, are understood? That's the thing. So that's the end of the story. That's the end of the story. So what is the EDM instruments, what is the principles and how it classifies, and what is why required modulation, how we will do a modulation techniques. Okay, that's the end of the EDM instruments. Tomorrow we will see the total station. We I won't show total station again. Last semester I shown a total station two classes, I think. I shown you two classes with video call. Again, no need to interest to show the total station, but I will show in the YouTube videos. Okay. So I think you already saw the total station. I shown in the last semester shown, and I will show in the different parts. Again, if you see the syllabus, again total station, what is the parts and how it is behaves. It's not a good idea, but we will show the YouTube videos how to do survey or what is the basic in theodolite settings. We will see some of the videos. I don't want to show again through video call. I don't want to show again the theodolite in a video call. You saw it, and I shown the last semester. Not required again and again. Okay, so that's it. If you have any problem, ask me. Otherwise, leave it. Leave it. I will send that link to your YouTube, your Google Classroom. If whatever the videos I shown in the classroom, I will post in the Google Classroom. You will check later. Okay, that's it.